On a September morning in 1957, Sheldon Roberts pulled his family station wagon through Mountain View, California, collecting 7 men along the way. They rode shoulder to shoulder, all of them between 27 and 32 years old, heading for the Clift Hotel in San Francisco to do something that American scientists simply did not do. They were going to leave a Nobel laureate together and build a company of their own. At the Clift, 2 young investment bankers named Arthur Rock and Bud Coyle were waiting. Robert Noyce, the last of the group to be persuaded, stood and talked for an hour about silicon semiconductors built from sand and fine wire, devices so cheap they could become disposable, so small they could change the bones of every machine in the country. When he finished, Arthur Rock pulled 10 $1 bills from his pocket. Each of the 10 men in the room signed each bill. Those 10 signed dollar bills were the founding contracts of Fairchild Semiconductor. That ride was the first mile of what the world would come to call Silicon Valley. But to understand why those 8 men were in that car, you have to understand the man they were running from. You are watching the American Electronics and Tech Channel, where we take apart the companies that built the electronic world, down to the circuit board and the engineer who designed it. This one starts with $10 bills and ends with $2 trillion and the map of modern technology redrawn. If that is your kind of story, subscribe and hit like, because the rise here is just as strange as what came after. William Shockley was one of the most brilliant physicists in America and one of the worst managers who ever ran a laboratory. In 1956, he shared the Nobel Prize in Physics for co-inventing the transistor at Bell Labs, and that same year he founded Shockley Semiconductor Laboratory in Mountain View, recruiting the finest young PhD graduates in the country. He promised them the frontier of solid-state physics. What he delivered was suspicion and control. Shockley ordered lie detector tests when equipment went missing. He insisted on pursuing a 4-layer diode that his own researchers believed was a dead end, and he blocked them from building the silicon transistors they knew the market needed. Robert Noyce had come from Grinnell, Iowa, a minister's son with a physics doctorate from MIT and a restless confidence that rearranged every room he entered. Gordon Moore was a quiet chemist who weighed every word before he spoke. Jean Horny was a Swiss-born physicist carrying an idea in his notebook that Shockley would never let him try. They had come for the laureate. They stayed for each other. And when Shockley made even that impossible, they decided to leave together. Eugene Kleiner wrote a letter to his father's financial contacts in New York, and that letter reached Hayden, Stone and Company, where Arthur Rock read it and saw something no one else on Wall Street could see: 8 scientists worth backing as a unit. Rock's colleague Bud Coyle connected them to Sherman Fairchild, the industrialist behind Fairchild Camera and Instrument. Each of the 8 put in $500 of his own money. Sherman Fairchild provided a loan of $1.38 million. On September 18, 1957, they resigned from Shockley Semiconductor and set up at 844 East Charleston Road on the border of Palo Alto and Mountain View, 12 blocks from the laboratory they had just left. Shockley called their departure a betrayal. No one knows for certain whether he coined the phrase the Traitorous Eight or whether it attached later, but it stuck. History would turn it from an accusation into a title. 3 teams formed under Moore, Horny, and Last, each pursuing a different path to making silicon transistors at production scale. They started in Victor Greenwich's garage, then moved into the building at 844 Charleston. Moore's technology yielded the best results, and by the summer of 1958, Fairchild had its first product, the 2N697 Silicon Mesa transistor. The initial batch of 100 units sold to IBM at $150 apiece, 30 times the price of a germanium transistor, for the onboard computer of the B-70 bomber. More units followed, shipped to Autonetics for the guidance system of the Minuteman ballistic missile. For a company that barely existed, these were not small customers. But the Mesa transistor carried a flaw that nearly ended everything. Tiny particles flaking inside the metal casing could short across exposed junctions on the silicon. And by late 1958, with the Minuteman contract at stake, the reliability problem was existential. The solution would not come from Noyce or Moore. It would come from the quietest physicist on the team, and his name is the one that most people have never heard. Jean Herney had sketched the essential concept in his notebook on December 1st, 1957, barely 2 months after Fairchild was founded. Instead of removing the silicon oxide layer after masking, as conventional practice demanded, he proposed leaving it in place to shield the delicate junctions beneath. The rest of the industry assumed the oxide would trap contaminants. Herney believed the opposite. In January of 1959, he filed a patent disclosure, and by March, he had a working device. He called it the planar process, named for the flat surface of the finished transistor, and one historian would later call it the most important single innovation in the history of the semiconductor industry. The 2N-113 planar transistor reached the commercial market in April of 1960. It solved the reliability crisis, qualified for the Minuteman program, and gave Fairchild a years-long monopoly in high reliability applications. Then, Noyce took Herney's breakthrough one step further. If the oxide could protect a single transistor, why not build multiple components on the same chip and connect them with deposited aluminum? In July of 1959, Noyce filed his integrated circuit patent. By late 1960, Jay Last's team had assembled the first working planar integrated circuit. Fairchild now held 2 inventions that would underpin every chip made on Earth for the next 6 decades. Yet Herney never became a household name. When Jack Kilby of Texas Instruments received the Nobel Prize in Physics in 2000 for the integrated circuit, Noyce was already dead, and Herney's enabling contribution went unmentioned. You can read that omission 2 ways, and honest history holds both at once. The Nobel honors theoretical priority, and Kilby's demonstration came months earlier. But the man who made mass production possible was invisible to the prize because his work looked like engineering rather than physics. The Cold War made the market. In 1962, NASA selected Fairchild's micrologic integrated circuits for the Apollo guidance computer, designed by MIT and assembled by Raytheon, which consumed roughly 5,000 Fairchild chips at $20 to $30 each. By the middle of the 1960s, NASA was buying 60% of every integrated circuit manufactured in the United States. The government did not invent the chip, but it purchased enough of them to make manufacturing scale possible, and that scale drove prices down to where civilian industry could follow. In April of 1965, Gordon Moore published an observation in Electronics magazine. The number of transistors on an integrated circuit had been doubling roughly every year, and he predicted the trend would continue. Moore's law was not a law of physics. It was a prediction made inside Fairchild, built on Fairchild's data, and it set the pace clock for the entire semiconductor industry for the next half-century. What followed was dominance on a scale American electronics had not seen before. Fairchild grew from 12 employees to 12,000. Revenue climbed from $1.3 million in 1959 to over $130 million by 1966, making the company the second largest semiconductor manufacturer in America, behind only Texas Instruments. A Fairchild advertisement of the era displayed a collage of Silicon Valley company logos beneath a single line. "We started it all. The products of that era deserve to be named because the engineers who built them deserve it." The 2N-113 planar transistor proved reliable enough for missiles and spacecraft alike. The micrologic NOR gate became the building block of the guidance computer that navigated Apollo to the moon. Bob Whittler, hired in 1963, designed the MUA-702 and MUA-709, the world's first monolithic operational amplifiers, giving Fairchild dominance in analog and digital circuits simultaneously. Don Forbes, Rex Rice, and Bryant Rogers invented the dual inline package in 1964, the tiny rectangular housing with 2 rows of metal legs that became the physical shape of the integrated circuit for 3 decades. If you have ever looked inside a computer built before the mid-1990s, you have held their work in your hand. But the profits generated in Palo Alto flowed east to the parent company, Fairchild Camera and Instrument, in Syosset, New York. The stock options that could have anchored the engineers were never granted generously enough. And the culture that made the breakthroughs possible, the flat hierarchy, the open collaboration across teams, taught every person inside Fairchild the same lesson. If 8 men could walk out of Shockley's lab and build this, then any good engineer could walk out of Fairchild and build the next thing. The departures started earlier than most accounts suggest. Semiconductor spun off in 1959. By 1961, Jay Last and John Horney had left to found Amelco, and Kleiner and Roberts followed within weeks. The original 8 split in half before the company turned 5. Bob Widlar and Dave Talbert left for National Semiconductor in 1965. 5 top managers departed in 1967, the same year Fairchild posted its first loss. Sherman Fairchild hired C. Lester Hogan from Motorola as CEO, and Hogan brought roughly 100 Motorola managers with him, gutting the original culture in a single stroke. In March of 1968, Moore and Noyce, the last 2 original founders still at the company, called Arthur Rock one more time. That summer they founded NM Electronics, soon renamed Intel. Andrew Grove followed. So did Federico Fagan, who carried with him the MOS silicon gate technology he had invented inside Fairchild's own research lab. Technology Fairchild had been too slow to exploit. Fagan would use it at Intel to design the first commercial microprocessors. Fairchild invented the planar process. Fairchild invented the monolithic integrated circuit. Fairchild invented the package that housed it. And then, Fairchild watched its people carry all 3 out the door and build the future somewhere else. The carcass changed hands for decades. In 1979, Schlumberger, a French oilfield services company, acquired Fairchild believing semiconductor expertise would strengthen its core business. It did not. In 1987, Schlumberger tried to sell to Fujitsu of Japan, but the United States government blocked the deal on national security grounds. National Semiconductor bought the remains, and when it too failed to make Fairchild profitable, it spun the company off in 1997, headquartered in South Portland, Maine, 3,000 miles from the valley it had named. On September 19, 2016, ON Semiconductor completed its acquisition for $2.4 billion, $20 a share. The NASDAQ listing was canceled. A startup founded on a $1.38 million loan, whose employees created Intel, AMD, National Semiconductor, Kleiner Perkins, and Sequoia Capital, sold for less than the annual revenue of several of its own children. Robert Noyce, the man they called the mayor of Silicon Valley, suffered a heart attack on June 3, 1990, after a morning swim at his home in Austin, Texas. He was 62. He did not live to see Intel become the largest chip maker in the world, or to grasp the full scale of what 8 men in a station wagon had started. But Fairchild's measure was never Fairchild. By 2014, researchers estimated that 70% of publicly traded Bay Area technology companies traced their lineage to Fairchild's founders and employees. The Computer History Museum calls it the first trillion-dollar startup, because although the company's own value never exceeded roughly $2.5 billion, its surviving descendants have been valued at more than $2 trillion. A 1986 industry chart traced 126 semiconductor companies directly to Fairchild alumni. Eugene Kleiner co-founded Kleiner Perkins Caulfield and Byers in 1972. That same year, Don Valentine, another Fairchild alumnus, founded Sequoia Capital. Those 2 firms alone would go on to fund Apple, Google, Amazon, and hundreds more. The planar process that Gene Herney sketched in his notebook on December 1, 1957, remains the basis of how every chip on Earth is manufactured. The building at 844 East Charleston Road still stands, marked by an IEEE milestone plaque. Most people who drive past it have no idea what happened inside. On a September morning in 1957, 10 men signed $10 bills in a San Francisco hotel room, and that was enough. There was no venture capital industry, no startup playbook, no place yet called Silicon Valley. Those bills passed hand to hand across a table at the Clift Hotel, underwrote a company that would invent the process, the circuit, and the package that made the modern electronic world possible, and then lose nearly every person who built it. Fairchild did not fail. It scattered, and everywhere it landed, something grew. Think about what that scattering actually produced. Intel came from Fairchild, and Intel built the microprocessor that put a computer on every desk in the world. AMD came from Fairchild, and AMD is now building the chips that power cloud data centers and gaming consoles across every continent. National Semiconductor came from Fairchild. Kleiner Perkins came from Fairchild, and Kleiner Perkins funded Amazon, Google, Netscape, Genentech, and dozens of other companies that reshaped how human beings shop, search, communicate, and heal. Sequoia Capital came from Fairchild, and Sequoia backed Apple, Cisco, Oracle, YouTube, WhatsApp, and Stripe. Pull the thread far enough and the lineage becomes almost absurd. A Swiss physicist's notebook sketch from 1957 connects in an unbroken chain to the phone in your pocket, the car you drove today, the satellite that guided your navigation, the server that loaded this video, and the artificial intelligence models that are rewriting software as you watch this. No other company in the history of American industry has ever generated that kind of downstream value while capturing so little of it for itself. Fairchild's own peak market capitalization never exceeded roughly $2.5 billion. Its descendants, by conservative estimates, have been valued at more than $2 trillion. That ratio, the gap between what Fairchild kept and what Fairchild created, is the single most important economic lesson of the 20th century technology industry. It says that in a knowledge economy, the value walks out the door at 5 o'clock every evening. And if you do not give it a reason to come back, it will build a competitor across the street. The parent company in Syosset never understood that. Sherman Fairchild never understood it. Schlumberger never understood it. National Semiconductor never understood it. They all believed they were buying a product line. What they actually needed to buy was a culture, and by the time they wrote the check, the culture had already left. It had driven away in someone else's station wagon, rented an office 12 blocks down the road, and started hiring. There is a deeper lesson here too, one that goes beyond stock options and management failures. Fairchild proved that the most dangerous thing you can do in technology is to be right too early and too completely. The company invented the right process, the right product, and the right package, all within its first 3 years. It dominated its market for nearly a decade. And then, the very brilliance of its people, the very culture of openness and initiative that made those inventions possible, became the engine of its own dissolution. The men and women who learned to innovate inside Fairchild did not forget how when they walked out the door. They carried the methods, the instincts, the confidence, and the contact list. Every departure made the next departure easier because every new company founded by a Fairchild alumnus proved that leaving worked. The precedent fed on itself until departure was not rebellion, but tradition, and Silicon Valley's defining behavior, the restless founding of the next thing, was written into the region's DNA by Fairchild's own example. Consider the geography. Before Fairchild, the American electronics industry was centered on the East Coast, around Boston's Route 128 corridor and the suburbs of New York and New Jersey. Bell Labs sat in Murray Hill. RCA sat in Camden. The great research laboratories of the post-war era were Atlantic institutions. Fairchild did not just build a company in Northern California. It built the proof that Northern California could be the center. And once that proof existed, once the talent clustered and the investors followed, the gravity became self-reinforcing. The apricot orchards south of San Francisco became the most valuable stretch of commercial real estate in the history of the world, and the name Silicon Valley, coined by a journalist in 1971, referred not to geology, but to the material that Fairchild had bet everything on when germanium was still king. One last thing deserves to be said plainly. Most of the 8 founders did not become famous. Robert Noyce became famous. Gordon Moore became famous. The other 6, Herney, Last, Blank, Greenwich, Kleiner, and Roberts, lived lives of varying fortune and varying obscurity. Jean Horney, the man whose notebook entry on December 1st, 1957, made the entire integrated circuit industry possible, spent his later years funding schools in Nepal and Bangladesh, building education infrastructure in the Himalayas, with the same quiet precision he once applied to oxide layers on silicon. He died in 1997. Julius Blank, the toolmaker who built the equipment that made Fairchild's first production runs possible, died in 2011. Victor Greenwich, the electrical engineer in whose garage the first experiments began, died in 2000. These men did not receive Lifetime Achievement Awards on national television. They did not ring the bell at the stock exchange. They changed the material foundation of modern civilization, and most of them did it before they turned 35. If you ever worked at Fairchild or at any of the Fairchildren, or if you ever soldered a dual inline package onto a board or traced a circuit back to a Fairchild part number, drop a comment below. Tell us the company, the year, and the chip. If you sat at a bench in Building 1 on Charleston Road, or tested wafers in the fab at San Rafael, or shipped product out of the South Portland plant after the name had already become a footnote, your part of the story matters. If you were at National Semi when Widlar arrived and turned the analog division inside out, or at Intel when Fagin's silicon gate process made the 4004 possible, or at AMD when Jerry Sanders scraped together enough funding to challenge the company that had just left him behind, you are part of this lineage. If you designed with Fairchild op-amps or spexed Fairchild transistors into a board that flew on a satellite or rode in an ambulance or sat inside a telephone switching station in a town no one has heard of, you carried the work forward. The engineers who placed those components, the technicians who tested them, the sales reps who drove rental cars to customer sites with data sheets in their briefcases. They were all part of the machine that moved Fairchild's inventions from a notebook in Mountain View into the infrastructure of daily life. The people who built the silicon know more about this story than anyone who tells it. Subscribe, because we are building the archive of American electronics here, one company at a time. We have the story of another American tech empire coming next, and you will not want to miss how it ends.